So in this example, we have 13 volts there, plus and minus. And this, okay, here there is a bridge. This bridge is very important in physics and measurement because very small resistances can be measured and you can get conductivity of water and maybe load cell, maybe some kind of deflection, deviation. Also, in the very sensitive balances that you use at homes, there are load cells and then there is this kind of circuit. This is called Whetstone bridge, okay? In this case, the resistance that you would like to measure, okay, is put in the middle, and then one of the resistance is variable, and then you change this resistance, and these are all known resistances, to make sure that the potential difference between A and B is 0, so that if you measure here by a multimeter, it will give you 0 volts. In this case, the unknown resistance that you place in one of these will be easily found. Now, these ohm values are given 1, 1, 1, 1, and this is 2. Okay, so this is how the ohm values are given. So now, in order to analyze this circuit, we have to put the current directions arbitrarily, of course. Say this is I1. Okay, this is I1, and this is I2, and this is I3. I arbitrarily pick these directions. I really don't know. I1 and I2 would be correct, but I3, I don't know. Maybe it's to the right or to the left, but I just pick this way. In this case, as you see, I2 and I3 are coming here, so that this current should be I2 plus I3. And now I1 is coming and I3 is leaving, so that this current passing through here should be I1 minus I3. Instead of giving another name to these currents, this is what I do. Now, both of these currents are coming, so when you add them up, this one and that one, this is the current I will have. As you see, I3s will cancel, and then I will have I1 plus I2 there. So I, which is leaving here, is just I1 plus I2. But I'm not using another name, so this is also I1 plus I2. This is practical, more practical, so that you can solve the problem quicker. Okay, so I would like to write the first loop equation here, okay? So if the current is passing through downward, it must be plus and minus, and this must be plus and minus, okay? Don't forget, again, this is plus and minus, this is plus and minus voltages, and this will be plus and minus there. Okay. So the first loop tells you minus 13, I'm writing, okay, plus I1 times 1, which is just I1 times 1, let me write it down, and then plus I1 minus I3 times this resistance, which is 1, again. And then there is nothing else, equal to 0. So the first loop, so this is number 1. This is number 1 loop equation. Number 2 loop equation, okay, is this. Okay, now start from this point and go now. As you see, when you go here, okay, it's minus I1 times 1, because the resistance is 1. Now I'm coming here, plus, okay, plus I2 times 1 again, 1. Now I have to continue here, again it's opposite, as you see, minus I3 times 1 again is equal to 0. These ones really don't make any difference, so that from this equation you can readily get I2 is equal to I1 plus I3. Okay, so number 3, this one, okay, I will write now, instead of this, now I will give you another technique. Instead of doing this loop analysis, I can do another loop, which is outer loop. Wow, this is interesting. So I go all the way around this circuit and then complete the whole circuit instead of doing this. You can also do this one also, but this is another one that you can use. Okay, minus 13 there. I'm moving this. Now I'm outside. I'm not really getting any information from the inside resistance, only outside ones. I2 times 1 plus I2 times 1, okay, and then plus I2 plus I3 times 2 now. Okay, and then there is nothing else, is equal to 0. As you see, this is simpler. So from this, I can find 13 is equal to, okay, 3i2, okay, plus 2i3. So this third equation turned into this. We have the second equation there, and the first equation basically giving you, this is I1 and I1, 2i1, giving you 13, which is equal to, so this is giving you 13, which is equal to I1 and I1, 2i1, okay, minus I3. As you see, we have these three equations. What we do is that if we put I2 into here, we get two equations. So I2 is I1 plus I3. Okay, so 3 times I1 plus I3 and then plus this, this is what you get. So these two equations that you get is just 13, which is equal to 2I1 minus I3. Okay, the first equation, the second equation is 13, which is equal to 3I1, okay, plus 5I3. And then now we have to solve this. So all these equations turn into just these two equations for I1 and I3. So we have two unknowns and two equations. Everything's okay, we can solve. How do we do this? Very simple, because this is 5i3 and this minus I3. So we multiply the first equation by 5, everything, and then just add them up. When you add them up, these things will cancel, and then we will have a single equation for I1 only. So if you do this, we will see that 5 times 13 plus another 13 will give you 78 is equal to 10 I1 plus 3, 13 I1, okay? So the current one is then 78 over 13, which gives you 6 amperes. So this is good. We have 6 amperes for I1. Now, obtaining, using this, one of these equations, either this one and that one, I can get I3, because I2 is not there. So I can really solve I3 there. So basically 13 will be equal to 2I1, which is 12, minus I3. From here, I can see that I3 is equal to minus 1 ampere. Wow, interesting. I will show you why. I will tell you why. And now, if I1 and I3 are known, I2 is obtained by just simply adding them up, because it was I1 plus I3, remember? I2 is equal to just the summation of this, which is 5 amperes. That's it. So 5 amperes is the result. So now, what we learned that the direction of the current 3, this one was wrong. So it was going to be, instead of this way to the left, and then this will be plus and minus. Now we really solve the circuit. Good. So we would like to get the voltages. Very simple. To get the voltages, I can just use the fact that the current and the resistance are multiplied. Okay. So here, for instance, I1 is 6 amperes and 1 ohm. This is 6 volts there. Okay. So I2 is 5 amperes times 5 is plus and minus 5 volts there. And then I2 plus I3 is just 4 amperes. 4 times 4 is 8 volts. 8 volts there. And here, I1 minus I3 is 7 amperes. Okay. 7 times 1 is 7 volts. And this is 13. As you see, it's okay, because 7 plus 6 is 13. Also, 5 plus 8 is also 13. So it checks. So what about the voltage here? It's I3, which is minus 1 ampere, and this is just 1 volt only. 1 volt here, plus and minus. So as you see, we really solve the circuit. All we have to do is just get this current I1 plus I2, which is just 11 amperes. So it must be the biggest current, 11 amperes there. So this must be also 11 amperes. Okay? So everything checks, as you see. As you see, 11 amperes is coming here, and then 6 plus 5 is 11, and then 8 plus, I2 and I1. What is I1 and I2? I1 is 6, and then I2 is 5. 6 plus 5 is just 11. Now the currents here are given by I2 plus I3, which is 4 amperes here. This is 4 amperes, 4 amperes. And guess what? If this is 4, this must be 7. Okay, 7 amperes. So everything is solved. So this circuit is totally solved. We have all the information given. So the potential difference between point A and B is 1 volt. What about the potential difference between this point and that point is 5 volts, this is 6 volts, this is 8 volts and 4 amperes spacing, 7 volts, 7 amperes, and totally 11 amperes, and this is 13 volts. So what should be the power of this power supply? The power should be equal to 13 times 11, because remember the power is I times V, okay? So 13 times 11, whatever it gives you, you get this 130, another 13, 143 watts. So this has to be really powerful power supply. So otherwise, if you don't have this power in this power supply, you will damage by connecting this circuit there. Okay, because the resistances are very small. Okay, so this was the example. Any questions now, you can ask me either by sending a message or just talking to me, turning on your microphone.